Okay, I'm going to assume that you paused it and you tried these. When you're setting up for division and decimals, you are going to set it up very similar to if you had normal numbers, or not normal numbers, but whole numbers. And so we've got 0.78 divided by 3.6. Now it is negative, but I'm going to come back to that. I'm going to look at it again, but it is negative. So we've got our setup there. Remember, the first number goes inside the box or the house or whatever you want to call it, but the first number always goes inside of that box or house. And now before we can divide with decimals, there's one step you have to take. We need to get a whole number on the outside of that box or that house. And so I'm going to move the decimal one time to the right, and that will give me a whole number 36. Now I do not need to have a whole number on the inside. It's okay to have a decimal on the inside. That works for us. But I do have to do the same thing. I have to move her one time, only once. So I'm not going to get a whole number. I'm not going to get 78, 7.8. And now I can divide. So I'm going to ask, how many times does 36 go into 7? Well, it doesn't. The decimal point comes up. How many times does 36 go into 78? Now we're looking at, is that 3 times? 3 times. 3 times 6 is going to give me 18. 3 times, oh, no, I was way off. 2 times. So I'm going to, so I tried. I gave it a guess. It didn't work. So I'm going to try again. So 3 was way too big, and so I'm going to go with 2. 2 times 6 is 12. Carry the 1. 2 times 3 is 6, plus 1 more is 7. And that just barely fits underneath. And so when we subtract, I've got 6 remaining. I can add a 0. You can always add more zeros. The zeros are there. There's 0 hundredths. There's 0 thousandths. There's 0 ten thousandths. There's 0 hundredths. There's 0 billionths. But we don't put them on there. We just remember that there aren't any. But we can always put them back in. And so we've got that 0. Now I'm going to pull that down. Times 36 go into 60. Well, 36 goes into 60 only once, because I know that 2 times is 72. That's too big. So I'm going to subtract, and I'm going to get 24. Add another 0. Pull it down. 36 into 240, I'm going to guess 6 times. But again, I'm not positive, so I'm going to guess. 6 times 6 is going to give you 36. 6 times 3 is going to give you 18. And we got 21 there. And at this point, I'm going to go ahead and have you stop. I maybe should have checked this a little bit better. But this one doesn't quite work the way we want it to. It's going to go a little bit long. On your assignment, on your tests, you will be stopping by at least the third. You may get to the third number, however, the thousandth place. However, I'm not going to make you go past that in your handwork. But if we do this, then we get, 24 again? Oh, here we go. So we got 24. And so we're going to have, okay, if I add that 0, there's that 240. Oh, so I'm going to get the same thing again. I'm going to get 6. And of course, if I do that, and I know some of you already know what to do, but if I do that again, I'm going to keep getting the same thing, and it's just going to repeat. And remember that when we have a repeating decimal, you can draw a line and say, well, it's 0.216 repeating, and that 6 is going to keep repeating. So that one did work out. That one did work out to be a repeating decimal point that we can handle. That was a long one. We do need to go back. We've got our answer, 0.216 repeating. However, we have a positive and a negative. Different signs, negative result. Next one, negative 2.05 divided by negative 5. So again, give myself a little bit of room here. We're going to set it up. The first number goes inside. Second number goes outside. I'm actually going to get rid of that negative for now, just so I don't get confused. And we've got a division problem. I already have a whole number. Don't have to worry about the decimals then. 5 does not go into 2. Can pull that decimal point up. 5 goes into 20 4 times. 4 times 5 is 20. Pull down that 5. 5 goes into 5 one whole time, and that works exactly the way we want it to with no remainder, 0.41. Now I've got a negative 2.05 and a negative 5. They have the same sign, it's going to be positive. Even if they're both negatives, it's still a positive result. And the last one, 4 divided by 0. Now this is where it gets a little bit tricky. 4 times 0, back here, 4 times 0, there's Shaggy, scared again. 4 times 0 is 0. Anything times 0 is 0. 4 groups of 0 is still nothing. If I have 4 divided by 0, 4 divided by 0 means I have $4, and I'm going to put those $4 in 0 piles. I'm going to divide it into 0 piles. You can't do that. You have to have at least one pile of those dollars. They don't disappear. You can say, well, I put it underneath my bed, but that's different. You can put them in one pile, but you cannot put $4 in 0 piles. You can't have 0 bank accounts with $4 in it. You have to have at least one place for those $4. And so 4 divided by 0, whenever you're dividing by 0, either like this or in this way here, it is undefined. And that's your final answer for that. 4 divided by 0 is undefined. We don't have a definition for that. That doesn't work. It doesn't even work with our imaginary numbers. It doesn't work with any numbers. You can't divide by 0. It's undefined. You can, however, take 0 divided by 4. If I have $0, I can give $0 to 4 different people. They each get nothing. They each get 0. So you can take 4, or you can take nothing and divide it into as many groups as you want, as many piles as you want. Every pile has nothing in it. That's fairly easy to do. I can take nothing and divide it into 1 billion piles. Every pile is 0. I can't take 4 of something and make 0 piles of it. That's impossible in our math. That's undefined. Okay, so that's it. Good luck on the pre-quiz and on the assessment, and we'll talk to you in class.